Welcome back. After watching that video, you should now be experts on irrational numbers. And this brings us upon our next part, which is we are going to be recognizing and simplifying irrational numbers. What's an irrational number? Well, according to that video, it is a decimal that does not end and does not repeat. What is the most famous irrational number of all? You all should know it now after the video. It is the pi symbol, pi, 3.14159. I think that's what it is. Let's make this bigger. 3.14159. 02653589793 and on and on and on, and it does not stop and it does not repeat. That is the most famous irrational number, and it's just not pi, it's any number containing pi. 2.4 times pi, 7 over pi, 3 pi plus 9, 4 minus pi. Anything with pi is automatically irrational. So that is this first column. The second one, or this first row, the second row is E, which we're not going to worry about. You'll get to that into Algebra 2. And then we have these radical symbols. Are all radical symbols irrational? No, because think about the square root of 9. The square root of 9 is 3. Is 3 a decimal that does not end or does not repeat? No. So it's not all square roots. It's square roots that when you put them in a calculator, or cube roots, that is equal to a decimal. So you have to actually evaluate them in a calculator if you don't know it off the top of your head. Let's go and down here. And these are the types of problems that I'm going to expect you to have to know how to do. I'm giving you 6 numbers there, and we have to identify which ones are irrational. The very first thing we look for is the most famous irrational, and that is pi. So we're going to look for pi first. So no pi, no, 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 no. Yes, right here. This is pi. Whoa, let me activate my writing here. All right, so we have pi here. That makes it automatically irrational. Then I'm going to move on to what numbers do I know are not irrational, meaning which numbers are rational. Well, rationals are any number that's a fraction. It's any repeating decimal. It's any terminating decimal. So if we look here, 9.3 repeating, that's repeating decimal. So remember, our definition up here is does not end, does not repeat. So because that doesn't fit the definition of irrational, it's rational. This one has a fraction in it, where we can make it 9 over 4. Either way, that is a fraction that is rational. And we're looking for irrational. So we're left with these 3, and they all have radical symbols. Does that mean they're all irrational? No. You have to put them in a calculator. I'm going to tell you that only actually 2 of them are equal to integers, or whole numbers. So we have the square root of 81. Well, we all should know what's the square root of 81? 9. And 9 over 1 is a fraction, rational. If I put the cube root of 8 in a calculator, I'm going to get an answer of 2, which is 2 over 1. Written as a fraction, rational. But when I put the square root of 42 in there, I get 6 point something, 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 and it goes on and on and on and on without repeating, without ending. It fills up the whole screen of the calculator. So that means it's equal to a decimal. So that is irrational. Okay? So irrational. Pi, irrational. Radical sign equal to a decimal. That's how you figure it out. Let's move down here, and I'm going to show you your next slide. Your next slide, this is what you're going to do. You are going to figure out which one of these is irrational, okay? And then I want you to explain how you know. So go ahead, move on to the next slide, answer this question, and then continue on with the lesson. Thanks.